So, we ended the last video by asking what makes the relativity we've seen so far special. Well, let's take a look at some of the equations. Things like the length contraction or distance. So let's do it in the most general case. Let's just go right to x primed. That's x minus vt all over the square root of 1 minus v over c squared. Similarly, t under the Lorentz transformations. Time, we have our original time minus xv over c squared divided by that same square root. So what is it about these that's limiting? Well, in all of these cases, when we've got two frames of reference, one is stationary and the other is moving, but at a constant velocity relative to our original frame of reference. So it's a car moving at a uniform speed, or a person walking at a uniform speed, or a spaceship flying at a uniform speed. So no matter what we've done, this v that we have up here for the speed of that reference frame has been a constant throughout. So we can't have an accelerated frame in this special theory of relativity. But in the real world, we can have accelerated frames. We are standing on a planet that's evolving and revolving at 900 miles an hour. Sorry, Monty Python thing. But we are on a planet that's rotating. If you're rotating and you're in circular motion, you're experiencing a centripetal acceleration. Which means if you're on the surface of a planet, you are experiencing acceleration. If you are in a rocket going to the moon, or maybe Mars these days is a more common target, you've got the thrusters behind you. You're also experiencing a force or an acceleration. In all of these instances, we are going to need a different set of rules for relativity. And the math gets much more complicated than we're going to summarize here. So from this point forward, we might have some final results quoted, but for the most part, it's going to be purely conceptual work. But we're going to start with the realization that Einstein had that allowed him to take that next step forward and get into general relativity. That'll be the topic in part 3.